And here is a little pin brush. Somebody gave me a pin brush and I drew a bull, and of course that didn't take more than what, 30 seconds? Certainly not more than a minute. And it's not bad. It's no great drawing, but it's the direction that I hope to be able to go because there's so many masters who've done it really well that man, I'd like to be that way when I grow up. Well, what I want you to see is that that's my personal direction. What I want to do is to do these fast drawings that could be expressive when they're done well. They are based, of course, on this kind of slower motion analytical drawing. Now, when I told you I was going to mention how analytical could mean a number of things. So let's be more specific. What I'm talking about when I say analytical is form analysis, because you can analyze for different things. Analysis. You can analyze for different things, but analyzing how something occupies space is what this is about. Can you see that somewhere in there, when I was worrying about how to draw this bull and I had this rib cage here, that I decided that the front was closer to me than the back, and so I've got a couple rubber bands around there. Why the rubber bands? Because those rubber bands can be important, especially on a convex creature, right? This creature is mostly convex. Those rubber bands will eventually turn into X and Y and Z lines that can really help us plane things up. So that's the reason why rubber bands around simple forms, because they help us analyze the position of the form. Now, take a look at this bull, and that'll help. If I wanted to light it from above, if I had a campfire down there, I would know now, because there would be an egg like that if the light were coming from below, it wouldn't make it past this curve, and so we get shade, maybe moonlight. If it's at night, it's a campfire, we might get the shade of the moonlight up this, and this would all be the warmth of the fire aiming at that plane. So knowing those forms allows us not only to change their position. I could make the bull's head look more toward me like this, see? Those eyes would be in there, those ears would be back here, those horns, wherever we got there. We can change the positions of things, but we can also change the lighting. But how would anybody ever know where that little bump goes? How would anybody know where this little bump goes? How would anybody know why that is a very sharp plane break, whereas this one is a smoother plane break? That is based on anatomy, and as you know, we start anatomy with the bones. Let me think for a moment. About whether I should take this up now. No, we'll come back to this. We'll come back to this. You ever notice how so many animals are drawn from the side? See, when we study human proportion, or apes, things that stand on their hind legs, one of the good ways to study proportion is to say that there is a certain height where we have the top of the head to the crotch. Well, the top of the head to the symphysis pubis, the crotch, on a human is about the halfway point of our body proportions. And then we can go from there and say that from the crotch to the knee and from the knee down to the foot is another thing we can break into two parts. And with a gorilla, it's quite different. Gorillas have so much shorter legs that they are mostly upper body and less leg. Now, we can do this with humans and to some extent with gorillas because they stand upright. But when you have an animal that does not stand upright, when you have an animal that stands on four legs, studying them from the front or from the back isn't the best way to study proportion. The typical way to study proportion of an animal, to make it so that we don't have one form in front of another form and in front of another form, it's hard to tell, we usually start at the side. So here we have a progression. Let me just back up with humans. I want to make a point. A human from the side, I always start this way. I have a proportional system in mind that is about like this, and I don't have to worry too much that those proportions are going to be too far off, because they are close enough to the truth of the way a human proportions are. Bridgman makes a big deal out of some great things with this that we don't have time to go into, but the axis like that, like that, like that, like that, like that, like that, like that. He likes the rhythms of those. I've never been that good at rhythms. Wish that I were. But a human is made to stand upright because our chest goes out and our pelvis goes back, and our upper leg has a kind of an arc forward, and our lower leg has kind of an arc back, and our foot pulls us up like this, and our head faces forward. Watch this. This is the most important part of this. Our head faces forward when we stand upright. When we get down on our forelimbs, our arms, like this chap, we can still face forward, but look what we have to do with our neck. Our neck is not in a natural position. And our legs are too long compared to our arms to make that comfortable. Whereas the ape, interestingly, because it has longer arms, because it is in a position with shorter legs and longer arms, is very nicely in a position to look forward when it has its arms down. That's the first point about proportions and how side views are going to reveal a lot about animal proportions. See, getting this guy into a single box is almost pointless. Getting this guy up here into a single box would make some sense. And we are unusual on the earth. We are the animals that stand upright in vertical boxes. Most of the animals don't. To understand us in other positions, we need to have a box for the head, a box for the rib cage, and a box for the pelvis. But I'm getting ahead. Look what we've got to do with the ape. We could put the ape in a box, but that's not too useful a box because it's too hard to remember, too hard to get at that one. Let's compare something, though. Humans are the big, marvelous, evolved animals, the ones that stand upright. Apes are almost there. Macaques, baboons, are monkeys, not apes. They're further away from us. And notice that they do pretty well on 4 legs. Whereas a monkey, a capuchin, a rhesus monkey, something like this, might as well be a cat, even though it's got more human-like features and human-like arms, because it can move its fingers around like we do. It scampers around like a cat. And when we have an animal that is on 4 legs that well, look how conveniently this animal fits in to a rectangle box, which helps us get the biggest, simplest, so simple as to almost seem not useful, but it is useful, simplest proportional measurement system that we can find. Going back over the questions, how long did it take Marshall to draw the analytical book? That might have been 5 or 10 minutes. I see you've got a box at the bottom of the skeleton. Do you all? Oh, not always, but we'll talk about that. Gannon. Hi, Gannon. I know who Gannon is. Gannon's an artist. Yes, when I'm demonstrating, I would always draw that box, Gannon. Let's go back to it. I think it was this one, wasn't it? No, it was this one. That one. Yeah, and of course that's not a very good box at the base of that, is it? We'll get to that. Let's get back to this. All right. A few quick observations. We'll spend 2 or 3 minutes on this. Horses tend to fit into fairly square boxes from the side. You say, that doesn't help me from the front. Hang on. We're starting from the side because that's the easiest one to see the proportions. Dogs, depending on the dog, there are dachshunds, of course, in this world. But dogs tend to fit into a fairly square rectangle as well. Cats most certainly do not. They are longer, stretched out, more horizontal, more flexible, I might add, than a dog, and far more flexible than a horse, and for that matter, far more flexible than a cow, which also fits into a rectangle that's horizontal, as you can see, but nobody would ever mistake this cow for this cat. There are some reasons. One is that we recognize the cliches, which aren't really cliches, there's the truth. That is, a cow's back is straighter, and a cow's back has a sacrum that points up, and so you get this angle that points up. And a cow has a lot hanging down there. But I think that it is the apparent stiffness of that cow's structure that is one of the factors. And when we see a cat and we see that shoulder blade going over there and we see that curve, and we just get a sense that anything that is that curved is going to be flexible, and anything that has these shapes on there like that is going to be less flexible. The cow and the cat have something in common proportionally, and the dog and the horse have something in common proportionally. And all this does is tell us that the biggest, simplest that we can do, proportions are like that. Well, we're going to need more dimensions, and we're going to get to more dimensions later in the semester. Let's see if I can do this. Let's fill this with white if it's possible. Yeah, we did it. Now, actually, let's delete, and then fill it. Okay. The way that will be useful in time is that if you are drawing a horse in a three-dimensional view, and you want to make sure that the proportions are not going to make it look like a cat, there will come a point where, having spent that time looking at that square and trying to figure out how this thing would extrude, will be useful to you. Now see, I'm not thinking square, but I would be aware that if I brought the thing's feet down to there, that would be too far, and if I ended the thing's feet right there, it would be too low, and it would make this horse look like a dachshund. So to know that a square from the side looks like that, and that a horse in the position that I drew it might have most of its body fit into a block that would be at about these proportions. See, that's a legitimate enough square. And then to know that the torso will fit in there in the top part, and the head will come out from the top and go over here. Yeah, those side view things do make a difference. But we're getting ahead. Let's get back to our final point of simplicity, and then we're going to look at details. Excuse me, we're going to start to break things down to the bone parts. We are the animals that stand upright. The other animals can stand upright, but they're not made to do so for long. And so we will mainly be studying the four-legged ones and a lot of side views to make the point. Okay, I'm going to take a moment to capture my thoughts and see if there's any questions.
If there's anyone just joining us and missed this earlier, we're going to be stopping periodically for questions. So you can raise your hand to talk and ask Marshall a question, and I'll unmute you. If you do not have a microphone, you can type your questions in the chat panel, and I'll relay that question to Marshall, or he will answer it for you.
Yes. Michael Hansinger, I think is how your name is pronounced, mentioned that we are thinking inside the box. You can't think outside the box until you've built a box. We're going to build the box. Build the box. The box will be built. Built. It will be. All right. Let's move on.